Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper trending on X, published on August 19, 2025, just 3 days ago. The headline finding is surprisingly blunt. Modern multimodal large language models stumble on a simple rotation task, nailing right side up and often upside down, but consistently failing to tell 90 degrees from 270. The paper is titled RotBench, Evaluating Multimodal Large Language Models on Identifying Image Rotation, and the implications for model training are quite significant. Beyond introducing a carefully filtered 350 image benchmark, the study tests prompts, auxiliary signals, rotation grids, voting schemes, and fine-tuning, finding only limited and inconsistent fixes for the 90 versus 270 blind spot. Building on that, the tweets spotlight RotBench and emphasize that frontier multimodal models falter on 90 versus 270, despite humans exceeding 98% accuracy, with moderate engagement around 60 and 30 likes. Here we are, looking at the teaser figure that sets up the task. The top prompt asks a simple multiple-choice question about how many degrees counterclockwise the image has been rotated, which is exactly what the benchmark measures. Below, you can see 2 example photos with black borders, each paired with the model's chosen answer and the correct label. The left panel shows a caregiver and baby, where the correct label is 270, while the model picks 0. The right panel shows pastries where the correct label is 180, while the model answers 90. Alright, we are looking at the full evaluation pipeline, which starts with an original photo that gets rotated into 4 versions, 0, 90, 180, and 270 degrees. The center panel shows the prompt and optional auxiliary inputs, so the model receives a question plus extra signals if provided. On the right, you can see per rotation predictions with checks and crosses, which roll up into separate accuracy numbers by angle. Finally, the bottom strip illustrates auxiliary information types, including boxes, depth, scene graphs, and a caption. Next, we are looking at the confusion matrix heat map, which summarizes predictions across 3 runs using chain of thought prompting. The diagonal cells show correct identifications, and you can see strong counts for 0 and 180, which indicates reliable performance there. The off-diagonal band between 90 and 270 is striking, because hundreds of 90 images are predicted as 270 and vice versa. This asymmetry highlights a clockwise versus counterclockwise ambiguity that persists despite otherwise good accuracy. Now we are looking at the main results table, which lists accuracy by rotation angle for several setups: 0 shot, chain of thought, and each auxiliary signal. You can see near-perfect scores in the 0-degree column across models, which confirms the right side-up advantage. Moving across, the 180 column is decent for stronger systems, while the 90 and 270 columns remain weak and unstable. The rows with captions, boxes, depth, or segmentation show only small, inconsistent shifts, so no auxiliary input reliably fixes 90 versus 270. Now we are looking at the small benchmark results table, which reports accuracy by rotation angle for several models and prompts. You can see near-perfect scores at 0 degrees across the board, which matches the earlier right side-up advantage. The 180 column is strong for frontier systems, while the 90 and 270 columns dip sharply, showing persistent confusion. The rows with chain of thought and rotation grids reveal mixed gains, because chain of thought sometimes helps 180, while rotation grids boost reasoning models but not weaker ones. Building on that, 2 takeaways stand out. First, modern multimodal models excel at right side up and often upside down, but they consistently confuse 90 with 270. Second, extra signals and chain of thought offer only small, inconsistent gains. A rotation grid or voting helps selectively. Thanks for listening. I am Alex, signing off.